Well, the technically largest flock you can have legally on 6,000 square feet. If that's real, then that's real. So, same program, same exact program. You might have noticed there's a program right above called Dist Draw. I want to share that with you too and tell you what that does. For those that are more visual, you might like that one better. So, program, Dist Fill. Okay, smallest X for my flock. In other words, when I say flock, I mean Max in the store with the box with the 4 peeps in it. We might have all roosters. Not likely, but we might. We might have all hens. The program takes care of every option in between. Press enter, boom. Binomial, it's 0.9, and at this point it's done. If you look at your distribution, it's in there. That's what we worked for about 25 minutes to build yesterday. That's why I gave you this. So you don't have to go through it over and over and over again. So you can go straight to the distribution. And now you can start analyzing things. Like when I told the guy, you mean there's a 1 in 3 chance I got a rooster in this box? This is how I did it. Now I didn't do the whole distribution in my head because I didn't have to. All I had to know was that's the chance of getting all girls. Notice it's going down. The chance of all girls is going down each time. That's because every time Max puts his hand in that bin, he's rolling the dice. He's rolling a 10-sided die. A 10-sided die, one of which sides has a B on it. And every time he rolls, he's got more of a chance of that B coming up in at least one of those rolls. That's the logic of, this is the mathematics, that's the logic of it. So tell me the situations I can be pissed about once they mature.
If you got all roosters.
All roosters. I'd never be pissed if I got all roosters. What else?
If you got only 1 female.
Only 1 female and 3 I'd be pissed there too. How about 2 and 2? What do you think? Some say yes, some say no. It's getting squirrely. It's getting close to like, maybe you shouldn't bitch. I mean, it's 5%, but that's weird. How about I get 3 and 1? I really have no right to complain about that. It happens almost 30% of the time. That's really nothing to complain about. That's pretty common, actually, 30%. And I obviously can't complain if I get 4 girls, but I wanted 4 girls. Make sense? Good. Now, if you're a more visual type of student, I gave you another program. Once you've run Dist Fill, you have to run Dist Fill first. But if you go back to Dist Draw, what it does is it just puts those points on a graph, which on small sample sizes like this is not super useful, but now you can hit trace and you can whoops, crap, I thought I hit trace. Oh, yeah, I hit trace for the wrong button. Hang on, sorry about that, guys. Let me do a re-zoom. You can hit trace and then scooch along the curve and the distribution numbers will come up for you. So if you're more visual, this will give you an idea. Now, honestly, it's not as valuable unless you start getting into larger and larger sample sizes. This is why I want to use Danielle's flock next. Well, 2 from now. I want to talk also about why we didn't get our chicks from Lava Ridge School. But here's your graph. Now my wife, her idea this year, which I loved, in theory, not in practice, but in theory, was Max's school is going to raise chicks. They're from eggs. They're going to get fertilized eggs from a farmer. They're going to raise them. I did the same thing when I was in grade school. I remember doing it. Some of you guys have done it too. It's adorable. They hatch one day. They're like, oh. Then they give the chicks away to people that want to keep in the backyard. And Jen's like, let's just get them from them. And I'm like, let's not do that. And why did I say let's not do that?
You want to visual samples.
Because this is not the distribution I'm guaranteed if I do that, right? Let's walk through and build. Let's suppose we brought 4 chicks home from that flock, or from that grouping, right? So back to the program, Dist Fill. I brought 4 birds home, yeah? What's the least number of girls I can have? Well, still 0. Still 0. What's the largest? Still 4. It's still binomial, whether boys or girls.
But you're probably
Assuming the science class isn't doing some kind of genetic kind of weirdness. What's probability?
less than 90.
0.5. Less than 90 I think is a safer bet, but I'm going to call it a coin flip. Because I'm going to assume that genders of chickens are the same as genders of human beings. 50-50. I could be wrong about that. That's a very Matthew 44 statement. Less than 90. I love that, Michelle. Thank you. I'm going to call it 50-50 because I'm going to assume it's the same gender as the... Okay, here we go. It's now done. I'm going to go straight, if it's okay with you guys, straight to Dist Draw. That's the distribution if the probability is 50-50. Now make peace with this distribution. Make peace with this distribution. If I got 2 boys and 2 girls, do I have a right to be pissed? No, because that's what
The most likely.
the most likely I should be getting that. If it's 50-50 and I buy 4 birds, I should get 2 of each on average, shouldn't I? How likely is it? Well, if you need a number, you can trace into it. It ends up being 3/8, 0.375. That's how likely it is. If I get all roosters, in this situation, do I have a right to be pissed? That's 6.25% is not all that low. Can I expect all girls? Unfortunately, that's the same probability because it's 50-50. This is like flipping a coin 4 times and getting 4 heads or 4 tails. It's just as likely. It doesn't matter. Heads and tails are equally likely. It's not this way with normal sex chickens. It's an unfair coin. But this is a coin flip, right? So really, this is why I didn't want to do that. Now, if I just want to have animals in the backyard, by all means. Unless my neighbors think otherwise about roosters. But basically, what chance do I have in this situation of getting a rooster? I said that very carefully. Of getting a rooster. That might mean more than one. What chance do I have of getting a rooster? If I buy if I take 4 of these little peeps home from Lava Ridge, what's the probability I've got at least 1 rooster in that batch? 94%! You see why? Every one of these situations has at least 1 rooster in it. This is the only situation with no roosters. That's 6%. That's all girls. Everything else, there's a boy mixed in somewhere. It's the same math I did with the guy at the store, except the number's obviously vastly different because of the probabilities going into the machine. You see how important that probability value is? It's so wickedly important because that governs the entire distribution. Fair? Believable. Ask me questions if that's not fair nor believable. Or neither nor believable. Yeah? Good. Let's build Danielle's flock. This is related to your runs of chickens. She asked, is there any mathematics behind getting runs of a straight run of chickens? So there are some banties, you said, the very small ones. Some chicks are not sexed, I guess because they're too small to sex, I'm guessing, or too hard to sex.
Could be the breed.
Right, for whatever reason they're not sexed, they just throw them all in a bin and you go buy them. What's the chance that when you reach into a bin of those and start pulling birds out, that you get all girls?
Could be the same.
It's actually not. It depends on how long your run is. How long a run of girls do you want? How many in a row?
41 birds.
41 birds! 1/2 to the 41st power. It's not going to happen. How many birds do you want? Say 4. 4 straight sex birds. Well, that's the chance. That's this one. That's the chance right there of getting 4 straight girls. It's basically 6%. Because it's 1/2 times 1/2 times 1/2 times 1/2. Think about why. Every time you go in and grab one, you only have a 50% chance of grabbing a female. So you have to get lucky to get flip tails or heads each time. And every extra bird is 1 more half factor. Every extra bird. You're going to see this distribution on your quiz for next week, the Gambler's Ruin quiz. What's the chance of losing every time? Losing every time. Or in this case, winning every time. Fair? So it's like this, but it's not exactly like this. It's like this in that you've got the half and half. It's not like it in that it doesn't always stop at 4. It stops at whatever you want it to stop at. Fair enough? Good. Carolyn?
I'm just trying to settle my brain a little bit.
Go,
We've
please.
generally accepted that the probability is 0.9.
Yes.
Then why are we saying that it's 0.5 for the...
Those are unsexed. Those
Oh,
are
unsexed.
unsexed. These are sexed
Okay.
chicks.
Okay.
Her question was, sex links, they're called sex links? I've heard that phrase too. Or is that like is that a gender?
That's a different breed.
That's a different breed.
It's like a dating
Yes.
site.
It's like it's a dating site. .per. So
How many roosters did you get out of 41?
that's what we're gonna do right now. Hold that. Don't answer that question.
I don't know yet.
Don't. Oh, she doesn't know yet. That's right. So let's tell her how many she can expect. Now, of course, you can answer that question right now. If Danielle buys 41 sexed chickens, how many roosters can she expect?
37 or
How many roosters? Please don't tell her 37.
3 or 4.
Right? On average, 1 out of every 10. So she's going to expect 1 out of 10, 2 out of 20, 3 out of 30, 4 out of 40, I guess 4.1 out of 41, right? 4.1 out of 41 if you use precision. We're using that same trick, n times little p, right? Number times probability. Of course, I did the rooster probability instead of the chicken probability. Is that okay? But it's binomial. They add up to 100% anyway. Let's build our distribution. Just be at peace with the fact you're going to get some roosters. I think we're pretty much proved that you're going to have to, right? So here we go. Dish filled, 0 through 41. I love teaching in Ben because you guys always have chickens and somebody on average has a lot of chickens. And it's just great to analyze the flocks. It's going to take a little bit longer to fill it. It's 0.9 still. These are not unsexed. These are sexed chickens, unless you want 20 roosters. It's going to take a little while to fill it. Little while. It's filling L2 right now. It's command 1, command done. I'm going to go straight to draw if it's okay with you guys. There are 42 dots on this from 0 to 41, including 0. What's the chance you're not going to get any chickens, Danielle? Pretty slim. 0. This is essentially 0, isn't it? There's a bunch of... Well, hit trace. Trace and right arrow. If you hit trace and right arrow, you can see, this is the chance right here, for example, of getting 11 girls and 30 boys. It's not going to happen. I mean, it says what this is saying. If it happens, you question your breeder. Right? When do the probabilities actually start getting measurable? Roughly when the curve starts looking like a what? What does this look like, friends? Say it again. It looks like a bell curve. That's not a coincidence. More on that next week. So we keep tracing. We keep tracing. We keep tracing. What's the most common outcome? Let's go find it. The most common outcome is 37 girls, which corresponds nicely to the fact that we told her she should expect 4 boys. There's your 41 birds. So, now notice, that only happens 20% of the time. It's the most common, but because there are so many outcomes. Now, when you get into these situations, and this is a little 244-ish, it's a little 244-ish, you can keep track of the cumulative probabilities. This is about 21%. 20%. We'll call it 20 to make the math easier. There's about 20%. So call these two together 40%. Make sense? Let's call this one here 13%. So we're up to 53% now. Fair enough? 53 plus 6 is about 59. Let's add this one in. 59 plus 17. What is that? 83? 73. 73? 73 plus 11 is 84. 84 plus 6 is 90. 90% of the time, we can expect between 34 and 40 girls. How's that? How's that? That gives a nice confident range, right? If you want more of a range, add more probabilities in. Danielle, what's the chance you're going to get all girls? Well, I don't think it's going to happen. Unless you're that 1 in 100, which that says, right? You might be that 1 in 100 shot, in which case, yes, go for it. You got the girl. I think you get a much larger chance of getting between, say, 34 and 40 than all 41, which probability says. Assuming that 90% is right. This is all based on that 90%. So assuming that's right, that's what we're going off of. And historically, it seems to be pretty accurate. I had a buddy a few years ago who had 7 chickens, and he got 1 rooster out of his 7 chickens. He was pissed. I'm like, don't be pissed. It was a coin flip whether you're going to get a rooster or not. He's like, what? I think there's a 47% chance you're going to get all girls. 0.9 to the 7th power. It's 47%. That means there's a 53% chance you're going to get a rooster somewhere in the box. Damn you, rule! Damn you if you want. It's math. Damn the math. I mean, it's the mathematics. It's not me. It's the damn birds and the math. Cool? Now, what I want to take away, I have some verbal kind of practice now to go through. Binomials are wonderful. They're gorgeous. I love them, and they're extraordinarily useful. But they're not everywhere. They're in a lot of places. I'm not saying they're not. They're in a lot of places. But they're not everywhere. What I've prepared up here on the PowerPoint is a bunch of experiments, some of which are binomial and some of which are not. And your job is to decide which are which. Does that make sense? In other words, having the tool is one thing, but knowing when to use it is another. Does that make sense? So yes, this is one of those things where, yeah, we know what the binomial is. Let's make sure we know how to use it as well. This becomes very, very important when you're doing your research or when you're consuming research to make sure you should go binomial versus geometric versus whatever.